This session, we will continue from the last point that we have stopped with the previous session. In the previous session, we have started the discussing on the algebraic solution methods for obtaining the solutions for inequalities. We have discussed the first three examples in the last session, and today I will start the session by starting from the discussion of the fourth example. Here it says about you are asked to find the values of x such that which satisfies the inequality which is given as x minus 4 greater than x minus 4 less than x times x minus 4 less than or equal to 5. But if you see about the inequalities that we have discussed so far, we had only one side. It means that for in a particular expression, we just had only one inequality sign. In the first three examples, we saw that it will be either greater than or less than, or else it may be greater than or equal, or else less than or equals. We saw one of those four signs in each and every expression that we had, or the inequality that we had. But once you see about this example, we can see that there are two inequality signs included in a single expression. Therefore, now we have to consider about both inequalities. Therefore, when we are finding out the values of x, then it should satisfy both of these inequalities. Therefore, we are saying this type of inequality as the double inequality. Then we can divide this expression into two inequalities, since we can see that there are two inequalities inside a single expression. Therefore, now what we can do here is first we will take the most left side inequality, then we'll take the quantity in the left hand side of the inequality as well as the quantity in the right hand side of the inequality. But here we are taking the terms up to the point that we meeting the next inequality sign. Therefore, we can see that in the left hand side of this inequality, we are having the quantity as x minus 4. Then we are having the less than sign. Then x times x minus 4 is here. Then we will take the expression after this point. It is because after this x minus 4, again we can see that there is another inequality sign. Then we can say it as x minus 4 less than x times x minus 4. Therefore, what we need to do is we need to find out a solution for the inequality, or find out the values of x which satisfies this inequality. Therefore, what we can do is we can take all the x terms into one side of this inequality, and then we'll take the right hand side or the other side of this inequality as 0. And here we can see that once we solve this inequality, we will get it as a quadratic equation. Taking the roots or finding out the roots for the quadratic equation, then we can easily find out the solution for this inequality. If you see about this calculation, here we can see that the values have given values are given as quantities are given as, in the left hand side we can see x minus 4, then less than x times x minus 4. First, what we need to do is we need to take all the x terms into left hand side, and I will try to make the right hand side of this inequality as 0. It is because here we can see that x times x, we can create a square term. Therefore, we can see about a quadratic equation. If you can build up a quadratic equation, by finding out the roots of this quadratic equation, we will be able to find out the appropriate solutions which satisfy this inequality. Therefore, I will take all the terms to the left hand side of this inequality. Then I will get x minus 4. Then this quantity becomes minus x times x minus 4, and it is greater than 0. Now what we can do is we can take the common factors, or the factor out this equation. or the inequality. Here we will take x minus 4 is common for both terms. Then we will take x minus 4 out of this, and the remaining quantity would be 1 minus x. 1 means it is from the first term and minus x from the second term, and this is less than 0. Once we factor out, then we can see that the equation we are getting, or the inequality we are getting, is x minus 4 times 1 minus x less than 0. Now we need to find out the area or the feasible region which satisfies this equation. Therefore, what we can do is we can write down the values of x by equating the factors to 0. Here we can see one value. Wow, the one possible value of x would be, it is 1 minus x equating to 0, then we will get x equals 1, and here x minus 4 equals to 0, we can get the value of x equals 4. But we can, even though we have identified x equals 1 and x equals 4, 1 and 4 will not help for us in this inequality. It is because we cannot see any equal sign in this inequality. Therefore, we cannot take the values. Therefore, we are just rounding on these two values, 1 and 4. Now we need to find out what is the feasible region, whether it is the first region, second region, or the third region, which satisfies this inequality. If you are able to take a value from the first region then and substitute it, then we can find out that if you are taking 0 here, then 0 minus 4, we'll get it as minus 4 times 1 minus 0. Here we are getting a value as minus negative value, and it satisfies our equation. Therefore, the first region satisfies this inequality. But if you see, or if you substitute a value from the region number 2, if you take the value in between 1 and 4, I will take value as 3. If you substitute 3, then we'll get 3 minus 4, it is minus 1 times 1 minus 3. 1 minus 3 itself, we'll get it as minus 2. Here we are getting a positive value. Therefore, second region is not a possible region for this inequality. In the similar way, if you substitute a value from the third region, again you will get this value as a negative value. Therefore, we can identify the possible region or the feasible region which satisfies this inequality as x is less than 1 and in the region of x is greater than 4. Therefore, what we can do here is, we have first identify the region, but we cannot take a direct decision. It is because based on this quantity, because this is a double inequality expression. Therefore, we have to think about the right hand side of this inequality as well. Then we have to, once we think about the right hand side of this inequality, we will get it as x times x minus 4 less than or equal to 5. In the right hand side of this equation, we can see that it is x times x minus 4 less than or equal to 5. Once you expand this equation, or once you multiply the bracket with x, then we'll get this value as x squared minus 4x. In the meantime, I will take the 5 to the left hand side of the equation by taking it as minus 5, then this will be less than or equal to 0. We are taking all the terms to one side and making the other side as 0. It would be easy for solving us the quadratic equation. Therefore, what we can do here is we can now factor out this equation, this quadratic expression, by equating to 0. Then we can factor out this as x squared minus 4x minus 5 can be factored out as x minus 5 times x plus 1, which is less than or equal to 0. Now, based on this inequality, now what we need to do is we need to find out the feasible region. Then by equating the values of the factors to 0, we can take the value of x. Here we can take x minus 5 equals 0. Then we'll get plus 5 here. then x plus 1 equal to 0. By equating this to 0, we'll get x equals minus 1. Now, based on this equation inequality, we need to find out what is the possible region, whether it is first region, second region, or third region. Therefore, what we can do is we can arbitrarily substitute a value from first, second, and third region separately and check whether which region satisfies this inequality. But prior to that, what we can do is we can find out that this inequality satisfies with x equals minus 1 and x equals 5. It is because we can see that the equality is included in this inequality sign. It is just less than or equal sign. Therefore, we can say that the values minus 1 and plus 5 satisfies this inequality. Therefore, if you take the values in the first region, value which is less than minus 1, if you are able to take the value as minus 2, if you substitute minus 2 here, 2 minus 5 is minus 7. Then minus 2 plus 1, it is minus 1. Then we can see that it is a positive value. Therefore, we can say that region 1 is not a possible region for this inequality. Then what we can do is we can arbitrarily take a value from the region number 2. I will take plus 1 here in this region, plus 1 in the sense 1 minus 5, it is minus 4 times 1 plus 1, it is 2. Then you will get a negative value. Therefore, it is minus in the sense it satisfies this inequality. Then region 2 is a possible region. If you are taking a value from the region number 3, if it is greater than 5, I will take it as 6. Then we will get plus 1 times 6 plus 1, it is plus 7. Altogether we are getting a plus sign. Therefore, here also we are getting the region as it is not a possible region. Therefore, we can take the values in the possible area is from minus 1 to plus 5. But what we need to now think is we cannot take these as two separate inequalities. They are not behaving independently. It is because the quantity is combined in this inequality. Therefore, we have to think about the common region for the first part of the inequality and the second part of the inequality. Therefore, what we can do is we can find out the common region which satisfies both these inequalities. Therefore, if you again draw the number line in this way, if you draw the or if you mark the points on the number line, here we can see it is minus 1, and here we had the value as 5, and then we had the value as plus 1 somewhat here and plus 4. Based on the second based on the first region, what we have identified those, it is greater than it is less than 1 and it is greater than 4 based on the first region. But if you think about or if you find out the values in the which satisfies the second region, then we have find out the values are it is minus 1 to plus 5. Therefore, we have to find out or we need to identify, we have identified the region in this way. Now, if you see about the common region for both of these areas that you have colored, now we can find out this region is common for both as well as this region is common for both. Therefore, now we can say that these are the two possible regions which satisfies both inequalities. Therefore, we can take the possible values in the first region or the regions which have intersected. Here we can take the value of x is less than 1 and it is greater than or equal to minus 1 since we have colored on minus 1, and we can take the next set of values as x less than or equal to 5 but greater than 4. Therefore, this can be taken as the feasible region which satisfy this double inequality. Therefore, this is how we are solving we can say whether this area, or rather than saying and here, it would be better if you are using or. It is because it can falls into the first region or the second region, but here we are taking and, it is because we need to take the intersection of these two feasible regions. Therefore we can take this as it can be in the first intersected area, or it can be have the value in the secondary intersected area. Next we will move for discussion of another example related to this. Now we can see here. Here it is in the way of fraction. You are asked to solve the inequality 1 over x minus 2 less than 1. 1 over x minus 2 less than 1. You are asked to solve the inequality. The fifth one, it is 1 over x minus 2 less than. Here, once when we are going to solve the inequalities in the way of a quotient or in the way of fraction, what we can do is rather than using the fractions, it is better to have the cross multiplication and make it in the linear form. Not the linear equation, it is in the linear form rather than saying it as a fractional form. Therefore what we can do is we can multiply the both sides by the x minus 2, and using the cross multiplication we can simply take 1 less than x minus 2. Now we can take the values. It is 1 plus, okay, we'll take it this way. Having the value, I will take all the values to the left hand side. It is 1 x minus 2 minus 1 less than 0, and rather than taking the cross multiplication, it is because this way is better. It is because once you are multiplying the quantity in the numerator, the denominator, we'll miss out what will happen when x equals to. Therefore we have to think about that as well. We cannot have the values of 0 here. It is because if we are getting x equals to, here we will get the infinity 1 over 0. It has the infinity, therefore we cannot follow that way. Then in that situation what we can do is we can take all the terms to the one side, and then it is better to take the common denominator. Therefore if you are taking the common denominator, we'll get this value as x minus 2, then 1 minus x minus 2 will be there, and we need to find out the region where this quantity less than 0. Therefore we can take this as 1 minus x minus times minus, it is plus 2 divided by x minus 2 less than 0. Here we are getting the value as 3 minus x divided by x minus 2 less than 0. Now we have to find out the region which satisfies this inequality. Here we cannot just think about the numerator only, we have to think about the denominator as well. But as the first thing what we can take is we can directly say that x is not equal to 2. We can directly say that x cannot be equal to 2. It is because if x becomes 2, then the left side of this inequality will become infinity. It means a finite value divided by 0, it will become infinite. Therefore we can say that x is not equal to 2. Therefore if x is equal to 2, then we cannot define this inequality. Therefore what we can do here is we have to find out the region. To find out the region, what we can do is um, here we can take the possible the values by equating the numerator and denominator separated to 0. Therefore we'll take the one value would be, if you are equating 3 minus x to 0, we'll get x equals 3. we'll get x equals 3. If you are equating x minus 2 to 0, then we are getting x equals 2. But what we know is we cannot take the value of 2. It is because this is actual. We cannot take this value. Once or if it becomes or if the value of x equals 2, then the inequality will not exist there. Therefore, we can say that x cannot be have the value 2. Now we need to find out the possible region of this. Therefore, we can take x is not equal to 3. It is because we cannot see any equality sign. Therefore, we have to just round up the round of the value 3, but we are not coloring it. And now we need to find out the possible region, whether it is in the first region, whether it is in the second region, or else it is in the third region. Therefore, if you substitute the value from the first region, a value from first region, we'll get the answer as if you substitute 1 here, a value which is less than 2. If you substitute 1, we'll get 3 minus 1, it is plus 2, divided by 1 minus 2, it is minus 1. Then we are getting value as minus 1. Therefore, we can take this as a possible region. Region 1 is a possible region which satisfies this inequality. And if you take the value from the second region, 2 and 3 will take the value as 2.5. Then 3 minus 2.5, here we will get a positive value. Then 2.5 minus 2, again we are getting a positive value. Therefore, altogether we are getting the final answer as a positive value. Then region 2 is not a possible region for the inequality. And if you move to the region number 3, here we can see that we have to find out a value in the region 3. We'll take the value as 4 since 4 is greater than 3. If you do substitution, here we'll get it as 3 minus 4, it is minus 1. Then it has to be divided by 4 minus 2, again a positive value. Then we'll end up with this calculation as minus or the negative value. Then region 3 is also a feasible region for this. Now if you find out the regions which satisfies this inequality, it is x greater than 3 and the region x less than 2. Here we cannot take the value of 2. Therefore what we can take is the possible values of x is less than 2, or we can take x is greater than 3. Therefore, these two would be the possible region for the inequality or the which satisfy this inequality. What we have to keep in our mind is, if you can see in the quotient form in the inequality, we have to take all the terms to one side, and by thereafter we can take the common denominator, and thereafter we can find out the solutions which satisfies the inequality. And now we will move for the example number 6. It is the solving the inequality given as 2 over x minus 1 less than 2 minus x. Now we'll see how we can solve this type of inequality. It is again somewhat advanced form of the quotient form of the inequalities. We are having the inequality as 2 over x minus 1 less than 2 minus x. 2 over x minus 1 less than 2 minus 6. Solving this inequality, what we have to do first is we have to take all the terms to one side of the inequality. So that I will take 2 minus x to the left hand side of the inequality. Then I will get this as it is 2 times or the 2 over x minus 1 minus 2 minus 6 is less than 0. Now we have to take the common denominator. When we are taking the common denominator, here we are having x minus 1, then 2 minus 2 minus x into x minus 1 less than 0. Therefore, we'll get this as is 2 minus. Once you do the calculation, then you will get it is 2x minus 2 minus x squared plus x less than 0. Here you can see x minus 1. Then we can take it is 2 minus, once you solve the quantity inside the bracket first, here we will get it as minus x squared plus 3x minus 2 over x minus 1 is less than 0. Then if you multiply the bracket with this minus sign, you will get this as 2 plus x squared minus 3x plus 2 over x minus 1 less than 0. Now we can see that quadratic equation has formed in the numerator. Then we'll get this as x squared, then minus 3x plus 4 over x minus 1 less than 0. Now we have to factor out this inequality. We have to factor out the inequality. But if you see about this inequality, first we need to find out whether what we are having the solutions for this inequality. Therefore, in here what we need to do is we need to find out the factors of this inequality. Then it is not easy for us to directly obtain the factors. Therefore, we'll try to find out the factors using the equation. If we are taking x squared minus 3x plus 4, here we'll equate to this to 0. Therefore, we'll take a equals 1, b equals minus 3, and c equals 4. Then we'll get the value of x equals this minus b plus or minus square root of b squared minus 4ac divided by 2a. Then we can take this as minus times minus 3 minus minus 3 plus or minus. Then we'll get b squared, it is minus 3 to the power 2 minus 4 times a is 1, c is plus 4, then divide by 2 times a. Then we'll get this as 3 plus or minus, here we are getting 9, then we are getting minus 16 divided by 2. Here we can take, we can get this as 3 plus or minus, here we are getting the square root of minus 7, it is 9 minus 16, it is minus 7, then divide by 2. This suggests that x does not have any, or x do not have real solutions. X do not have real solutions. Therefore, we are not going to solve this inequalities, because in the we need to find out the real solutions. We are just discussing about the finding real solutions. Instead of finding the real solutions, we can find out some imaginary values, taking this square root of minus, by taking square root of minus 1 as I. Therefore, we are not going to discuss those complex roots in this session. Therefore, we can say that x do not have real solutions, and we are not going to solve this inequality thereafter furthermore. Okay, now we need to move for the next part of the discussion of the inequality. So far we have discussed about the algebraic inequalities, and now we will move for the discussion of the modulus inequalities. Here we can see the modulus function. If you can have the fx, the function as fx, suppose that you are having the function fx, and if you are taking the modulus of this function, we are denoting by this notation, and we are saying this as the modulus of fx, and the modulus of function fx can be defined as a piecewise function in this format. Therefore we can say the modulus function, and if fx is greater than 0 or equal to 0, we can say it is equal to fx, or else if we are having the value of fx less than 0, we are getting this as minus fx. Therefore, if you are getting the positive values, we are directly take it as fx, but if you are taking fx less than 0, we have to take it as minus fx, and anyhow we are, therefore this is the piecewise function for the modulus function we are taking. And in the further sessions I will discuss about the modulus function separately. Therefore just have an idea for the modulus function. We can have this, if we are having fx in this form, then we can divide it into two forms as fx and minus fx. Therefore by taking this or the consideration of this concept, we will try for the solving inequalities which are associated with the modulus functions. Therefore, if the function inside the inequality is a modulus function, we are saying such inequalities as the modulus inequalities. Therefore, now we'll try to find out the solutions of this function or for the function. Here we have to find out the solution set of modulus of x minus 4 greater than 3. Therefore, first we need to find out the two domains or the two regions which behaves this function. Therefore, simply we can take one is less than this, in this region, this fx less than 0 and fx greater than or equal to 0. Therefore, by taking the concept of this modulus function or this piecewise function of the modulus function, piecewise form of the modulus function, then we will try to find out the solution for this given inequality. Here what we need to find out is, we have to find out the solution for modulus of x minus 4 greater than 3. This is the inequality that they have provided for us. But what we know is, if you are having the modulus function as the modulus fx, this can be denoted as the piecewise function. It would be equal to fx if fx greater than or equal to 0, and this would be say as minus fx if the region of x where fx less than 0. Now taking consideration of this concept, what we are going to do is, first we are going to identify this fx and minus fx. Therefore, if we let if you let fx equals x minus 4, here what we can consider is, rather than saying it as fx equals x minus 4, we'll take the consideration of this fx greater than or equal 0 and fx less than 0. Therefore, if you are considering the concept of fx greater than or equal to 0, then we can say this as x minus 4 greater than or equal 0. Here we can say fx is uh, a value, or fx is the function we are taking as x minus 4, then we'll take this as x is greater than or equal 4. And if you are consider about the next part, it is fx less than 0, fx less than 0, then we are getting this as x minus 4 less than 0. Here we are getting x less than 4. Therefore, if you see about this function, we can see that the two domains are x less than 4 and x greater than or equal 4. Using these two, or the using the concept of the piecewise function, first we have identified the domains of this function. Therefore, the domains of these two functions are said to be x greater than or equal 4 and x less than 4. Now we'll try to find out the behavior of the function in these two domains. Therefore, if you see about the first part, if x is, I will take the value as the first domain, I will take as x less than 4. What we know is if x is less than 4, we have taken x less than 4 by considering fx less than 0. But what we know is if fx less than 0, we are having the function as minus fx. Based on this concept, what we know is if fx less than 0, we are having the function as minus fx. Therefore, in this region, we can find out the value of fx is equal to minus x minus 4. Now we need to find out the region that it is greater than 3. Therefore, we can take this as inequality as minus times x minus 4 greater than 3. Then we'll get it as minus x plus 4 greater than 3. Then it is minus x greater than minus 1. If you multiply both sides by minus sign, we'll get this as x less than 1. Therefore, in the region of x, for this as in this minus fx, we will get the function as x less than 1. But if you see about the next region, if you see about the next region, we have to think about the region where x greater than or equal 4. Here what we are doing first is, first we have identified the domains, thereafter we are finding out the behavior of fx, or what will happen for the fx at the particular value of x. Therefore, if x is greater than or equal 4 in this region, what we can see is fx behave as plus x minus 4. Here it is, under this piecewise function, fx greater than or equal 0. Here we will take it as fx. Then we can take this as x minus 4 is now greater than 3. Therefore, we can take x is greater than 7. Therefore, we can find out the region. We can say it is x is greater than 7, or else the region is x less than 1. Therefore, we can rearrange this as by taking the lower value for the left hand side of the inequality. Therefore, we can take the region is x less than 1 or x is greater than 7. And you can show it using the number line as well, 1 and 7. And these are the possible regions which satisfy this inequality. Therefore, what we have to do is, if we are performing the calculation based on the modulus or the modulus inequalities, modulus functions or the modulus inequalities, first we have to find out the domains. To find out the domains, we need to take the concept of the piecewise function for the modulus function. Thereafter, we need to find out by using these domains, we need to find out what would be the function in the region of x greater than 4 and x less than 4. And using this function, we have to get the solutions for the inequality. After, we are just taking these domains to identify the behavior of the functions in that region only, and thereafter we are finding out the solutions for the inequality just by taking the piecewise functions only. Therefore, using the piecewise functions, we can simply take out the solutions for the inequality. Okay, here we have two more examples I have included. Then here it is asked to find out the solutions for the modulus of x minus 4 greater than 2 times x minus 2. Here also first the domains are identified by considering x minus 4. Therefore, by taking plus this taking greater than or equal 0 and less than 0, the two domains were identified as x less than 4 and x greater than or equal to 4. And in these two regions, in these two domains, the appropriate functions were identified. If x is less than 4, the function would be minus fx. Then we need to substitute minus fx and it should be greater than 2 times x minus 2. Therefore, solving this inequality leads to the solution as x less than 2. Therefore, the the region gives the value as x minus 2. Actually, we have to consider the intersection region here. I have missed that part in the previous. Here it is actually if you see about these two regions, for the first part I will mention it here as well. We have to consider the intersection region. Here it is x greater than or equal 4 and here it is 7, and the regions are, if it is greater than or equal 4, the region would be this, but the next region says that it should be on this. Therefore the region will be definitely x greater than 7. And here we have to take the first region. The first region is mentioned as x less than 4, and here we are having 4 which is less than 4. Then next region is x less than 1, therefore we have to take this region. Therefore the intersection region would be just it is less than 1. That is why I have directly taken this as x greater than 7 or x less than 1. Therefore, using the same concept, okay, I will redo this calculation. I completely do the calculation for the example given in the example 8. Here it is given as modulus of x minus 4 greater than 2 times x minus 2. First, we are finding out the domains. To find out the domains, what we need to do is we need to find out fx greater than or equal 0, and we are taking fx less than fx greater than or equal 0. Here we will take x minus 4 greater than or equal 0. Then we will get the region as x greater than 4. But here we'll get this as x minus 4 less than 0. Here we'll get this as x less than plus 4. Then in this region, if it is greater than or equal 0, what we know is the modulus fx is defined as a piecewise function. It is written as fx if fx greater than or equal 0, written as minus fx if fx less than 0. Therefore, by taking consideration of this concept, we can take in this region x is greater than 0. We can take it as x minus plus fx, it is x minus 4 greater than 2x minus 2. Then in the next region, we can take this as minus times x minus 4 greater than 2x minus 2. Now we have to solve these two inequalities. Here we will take all the x terms to left side. Here it is x minus 2x. We will get it as minus x, then greater than. It is minus 4 becomes plus 4. Then we'll get plus 2. Therefore, we'll get this as x less than minus 2. If you solve this bracket, then it is minus x plus 4 greater than 2x minus 2. Here we'll get this as minus x, 2x becomes minus 2x. Here it would be minus 3x greater than minus 2. Here it is minus 4, it will be minus 6. Dividing both sides by minus 3, we will take this as x and 2, and the sign should be changed. It is because we are dividing both sides by a negative sign. Now we need to find out the solutions. Therefore, to find out the first region, we can take these two inequalities. Here it says that the region x less than minus 2 and x is greater than or equal to 4. Therefore, the first region would be x greater than or equal to 4 and x less than minus 2. In the second region, here we can write it as x less than minus 2 or x greater than or equal to 4, and here we'll get this as x less than 4 and x less than 2. It is x less than 2, therefore the intersection region is taken. Therefore, simply we can obtain the answer. In here we can say that here the region is x less than 2, and if you see about this region, here we have to take the intersection. Therefore, we can take no intersection, no intersection. But in the second part, we can see the intersection area is x less than 2. Therefore, we can say the area which satisfies this inequality is x less than 2. Therefore, this would be the only region we can find out that this inequality satisfies. It is because in the first region, we cannot find out any intersections. We just identify the two regions only. No intersection was there. But here x less than 4 and x less than 2 was considered. Therefore, the intersection region is just x less than 2. Therefore, it would be the final answer which satisfies this inequality. Therefore, we can say the solution set is equal to x less than 2. And similar manner, you can try for the next example. I have provided the answer for the next example. And this is all what I need to discuss under this session. And thank you all for your participation.